So a slight update in my affiliation. I'm actually just moving to I have just joined the University of Bristol. I'm still affiliated with the university I was at in Hong Kong, the Chinese University of Hong Kong, where I've been for the past 13 years. So what I'll be talking about in terms of my experiences were actually over the last 5 years in Hong Kong. So that cultural context may be useful to keep in mind. Let me maximize this. Actually, as you know, the pandemic hit us maybe a month or two earlier than you, so we had to segue to online classes in early February. And indeed, previous semester there were political issues, so we also had to suddenly switch to online classes in the previous semester. So even though the context of this class, which I've been teaching for the past 5 years, initially was face to face, traditional in class lectures. But over time it segued to flip classes, and then suddenly perforce online flip classes. So some lessons and some ideas, and I'll focus on some of those. Perhaps more than the technical aspects, like the last speaker, I will focus maybe more on the philosophical underpinnings of what, in my view, makes such a class work. Okay. So to jump into it, teaching math in the best of times can be challenging. This can be one's teaching experience. Student engagement can be a challenge, right? But in the particular class of teaching, just to highlight the level of attainment, so it's a pretty intense class. It's supposed to be a year one, like undergraduate year one, linear algebra and vector calculus class. So first 5 weeks is linear algebra, and then it segues to 4 weeks of vector calculus, with a little bit of finite fields and even some introduction to one week of crash course to analysis thrown in. Just because, this happens to be a very special class. It's much more intense than the normal classes, and students engage with the material. So here are examples of questions that they've been able to solve, theorems they've been able to prove really in exam settings, in time-limited exam settings. They're able to derive the Cayley-Hamilton theorems, Gilbert-Parshomov codes, Rayleigh coefficients for matrices. So they're really able to do a lot, right? Much more than I was able to as an undergraduate, as a year one undergraduate. They do, projects on quantum computing. I just view that as applied linear algebra, tomography, game theory. Again, this is way more than I thought I was capable of in my first year of university. So I'd like to step through beyond just the attainments, like what maybe is some of the philosophical underpinnings that I believe help get to this level of attainment. As I mentioned, this was done in a flip classroom setting, which almost all of you all certainly already know. In a normal classroom, it's a single point of failure. The instructor teaches, and then the students have to do work by themselves at home. But in a flipped classroom, the baseline data delivery, what is a definition, what is the basic theorem statement, what is the basic proof, that's done by a video lecturing, and then there are interactive exercises done, well, traditionally in a face-to-face setting, in a classroom setting, but due to the pandemic, we had to segue those online and so on. So the first part did not change much. Those videos were still posted before class time online. And then synchronously during classroom time, there were synchronous activities, which we managed via Zoom breakout rooms and so on, which I'll talk about. But again, I'll be focusing more on I believe the interaction structures rather than on the specific technical details. So the fact that it is flipped at this point perhaps is maybe familiar to many of you. You may have experimented with those things, but I think it helps to think through how to motivate take participation structures within flipped settings to create a community of learning. So let me begin with an anecdote, which I think sets the stage. So there's this really nice book by Michael Sandel at Harvard. So maybe it's fair to characterize his central thesis as that there are at least two primary motivators for human behavior. On the one hand, there's market incentives. It's a zero-sum exchange. I give you A, you give me B. On the other hand, there's community norms. Be polite to people, do unto others as you would have others do unto you, and so on, right? So an anecdote that he has in his book is, well, there's a Israeli daycare center where a perennial problem was, well, parents would be late picking up their kids, right? People have busy lives. And of course, this is inconveniencing to the people who work at this daycare center. So they decide to start fining people who come late. And what happened? Well, maybe predictably in hindsight, people suddenly viewed it as a service. They started paying money, and immediately the amount of the number of people coming late was shot up considerably. So this is an example of how a community norm being substituted by a market incentive can actually have a negative outcome. Can actually get you the opposite of what you thought you wanted from here. Okay. So what is the relevance in this context, in the context of teaching and learning, in particular in the context of teaching and learning online? So we view our role as instructors as creating a community of learning where students act as peers, learn from each other. Flipped classrooms are great at doing that. But often the way we instantiate the classroom is like a marketplace. We view the homeworks and exercises and exams they give us as goods. They have to give us a good homework or give us good exams, and in exchange we give them the scarce resource of good grades and so on, right? And predictably, then students, being entirely rational creatures, some examples notwithstanding, what ends up happening is, well, they start focusing on the points, often to the detriment of the actual learning, right? So the thesis here, and I'll give examples from my classroom, is that you can use market style incentives to start nudging behavior deliberately structured in a way so that they start doing things which are better for the learning community. And if you do it in a careful enough manner, then these nudges become self-reinforcing. Even when the nudges are no longer active, then they still behave in a good manner. So I'll give examples, for example, of bonus points. So bonus points get students, starting to teach each other and so on. And then even once they saturate their bonus points, they still keep accumulating them. We have numbers showing the median student blew past their saturation limit in bonus points, just as an example. So as previous speakers have done, I'll be using the Bloom taxonomy as a framing device just to talk through levels of student attainment. And at the baseline level, it's just basic data delivery. What are some of the definitions and theorem statements and so on we want to focus on. At the top level, it's creativity, and all of this again is in the context of a single semester, 12-week semester math class, where at the very end they even had projects to submit on the basis of the linear algebra they were learning, right? So this is a very dense slide, and I don't really expect like everything to come through, but what I'd like to focus on is the following. So as an instructor, we design specific learning activities. So for example, videos interleaved with certain interactive exercises, which students do by themselves at home. And then at the end, we want them to get to something like a project, a capstone style project, which allows them to explore, self-explore with some guidance from the instructor, and these things in a more detailed level. So we'd like them to move up this taxonomy. We'd like them to gain a deep understanding of what they're learning. So there are incentives that you design, and by the way, different pieces of these are interchangeable. The different learning activities, the different incentives that we design, and the different community outcomes can all be different. It's nothing here is written in stone. I don't believe this is the single best way to instantiate a class. Perhaps my primary message or my primary experience over the last few years in doing this is that one just has to be mindful of what one wants students to do, what types of attainment one wants, what types of community interactions would be helpful to attain this, and then design the corresponding incentive structures. And we have multiple examples, but I'll share maybe 2 or time permitting 3 of those. So moving on. So as I said, the first couple of layers, well, there are just videos, short videos interleaved with exercises. And in this case, the incentive structure is a pretty crude one, but effective. So, there are automated exercises interleaved between the videos, and points are deducted for not doing them. And we keep track these, and 95% of the students watch and do most of the exercises before the synchronous sessions start, right? So earlier classrooms, now on Zoom. All right, so now they come to class, or they come to the Zoom session online, And they're assigned into breakout rooms, so 3 students per group. Apparently, research shows 3 is a good number for a group interaction. Anyway, and now they're supposed to collaboratively solve reasonably challenging questions over a period of a week. So they have 2 or 3 sessions where they synchronous sessions, which used to be classroom time, but now is time for problem solving with some feedback and so on. So one challenge, at least in an Asian context, is to get students to talk to each other in a classroom setting. Like normally, it's viewed as, it's a pretty traditional classroom setting. It has been where the instructor just talks and students are supposed to listen. So how do we start interaction? One thing that was quite useful is what we call dice grading. So at the end of the week, each student in each group is supposed to submit a solution. We randomly select one of those 3 submissions, and every student in that group gets equal points for that particular solution. Now, the incentive structure here is, well, if somebody truly knows the answer, feels like he or she knows the answer, then the incentive is to describe their thought process to the group because of the grading mechanism, right? But to balance it, like even though only 20 points were allocated in the course syllabus for this activity, over the course of the semester, there were 50-ish exercises. Every student who actually showed up and participated easily saturated this component of the grade. So it's an example of something where points are used to incentivize positive structure. And indeed, like the vast majority of students attempted every single question that they were assigned. So it's an example of how once you set up the norm, after a few weeks, they stop worrying quite so much about how many points they're earning for this, and they start focusing on the content, right? Okay, so a second example. So now they've attempted these solutions for a day or so, and then in the next session, they're expected to start, or actually near the end of the first session, they start posting it on the class forum. This is the Piazza, we use the Piazza class forum as the class forum. And in real time, my teaching assistants in Hong Kong for this class, for 60+ students, my TAs and I were viewing this forum, giving feedback. We encourage creative solutions. We encourage people to post solutions even if they don't know the answer. Bonus points. So the incentive here is bonus points for solutions or incorrect solutions if they're interesting mistakes or whatever, even if they have trouble solving them. So this systematizes the learning process. It shows people that there are many different ways to crack this particular egg and so on. So, and the conversation ends up being more useful than a clean solution at the end. Students end up liking it quite a lot. We synthesize this discussion. So in the last session of the week, or the penultimate session of the week, we synthesize this, highlight some interesting discussions that have happened, maybe invite some groups to have a discussion. This was done during the class, pre-pandemic. During the pandemic, I would do it on Zoom. And then finally, one final example I know I'm almost out of time. So one final example of an activity that was able to leverage this community structure. So, so marketplaces are great at distributed learning. And the idea here is, well, so for a review session, each student gets a row of a publicly viewable spreadsheet. Each concept during that week in class is a column, and students are supposed to self-report their level of understanding for that concept. And then every student gets some coupons. These coupons are worth some points, and then they can go seek people to help them. So, they go to different Zoom breakout rooms, they ask for help, and then they report if they got help, and then we give them points. So as an example, just before a midterm exam, in a 2-hour session, students were able to exchange 100, so out of 60 students, like 100+ concepts were exchanged, 50+ different questions were exchanged, 2/3 of the students got help. It was viewed as a tremendously positive exercise by all the students, right? All right, so there's a few others, but I won't highlight those. Let me just land on this slide over here. Basically, I view the driving mechanism of truly, engaged classrooms being valuable in getting like a superlative student achievement. And it's been challenging for all of us to do this in a pandemic world where we're all just online, but I do believe it can be done with the right technologies, and I've seen wonderful examples by the other speakers. Let me stop there.
Thank you, Sid. There's some really useful kind of teaching strategies there. There are some questions coming in.
Yes.
So first of all, how do you assign the groups of 3 when working together?
Yeah, so our over time we've realized that, or we feel, and we have data to back it up, that it's best to let students first try to find their own groups. If they have trouble, we help them assign them, but we monitor them. If there are groups that are struggling, then we gently intervene. We have a discussion. We say, well, it seems like some of you are having trouble. Would you mind if we do some reassignments and so on? So since the idea is to leverage community structures, instead of mandating that people who may not get along with each other have to work with each other, we prefer to let them first try to find their own communities, but then also monitor. I think that seems to work reasonably well.
Okay. Another question regarding the DICE grading.
Yes.
How do you ensure that students explain their answers rather than just copying from each other? So they were expected to submit 3 different solutions, weren't they?
It's a fair statement. So as a benchmark, when we first started doing this, in homeworks, that was often what, at least in our context, that's often what would end up happening. And then if we had a rule about no plagiarism, we would have to fight it. Here we explicitly allow that, but from our point of view, what we used to observe in the in-class sessions was that, well, if they're sitting next to each other, if they don't understand a step, well, at least they'll ask that, right? And we would have been walking around with them. So then we would have noticed something happen. We would notice discussions happening. If a group was particularly quiet, we would go talk to them. So those are the advantages of a flipped classroom. In a Zoom setting, we flipped between the different Zoom breakout rooms, and then we try to get a conversation started. So our expectations are low, but even if they end up purely copying, my view is just the role of writing something down is also more valuable than, so we only accept written solutions. We don't accept, typewritten solutions or anything like that. So there's value in at least doing that baseline amount of work.
And what's the advantage of getting them to each submit a solution rather than working together to produce one solution?
So if they had only submitted a single solution, then it is quite possible that someone who is perhaps a little bit more competent or feels more confident would have done the whole work, and nobody else would have engaged. Here, the idea is, well, at least everyone in their own handwriting has to submit a solution. So at least a baseline amount of work has to happen, right? I mean, it's simple-minded, but seems to work.
Okay, thank you again, Sid. We're just about out of time. I'm going to just hand over to Rob before we go to the break.
All right.
So thank you, Claire, and thank you, Siddharth, again. And also, once again, thanks to Stephen for those talks. Again, lots of interesting things highlighted there. Siddharth, I particularly like the mate idea. I'd be interested in looking at that in a bit more detail, without doubt. So again, just to emphasize, we are taking a break now, and it'll be another 15-minute break. So we'll be back at 12:10.